There is one more important point here, where in some books you will see the formula which has n pi or L instead of n. It is just because if you define the function f of x in interval minus L comma L or from 0 to 2L, L is the length. If you remember last time we had minus pi comma pi or from 0 to 2 pi. This time I have minus L comma L or 0 to 2L. Here the period shows the length of something. Normally we write the Fourier series in a form with cos nx and sin nx. It is because the function is defined in interval minus pi comma pi r from 0 to 2 pi. If you define the periodic function in interval minus pi comma pi r from 0 to 2 pi, you have cos nx and sin nx. But if you define the function f of x in interval minus L comma L r from 0 to 2L, you have cos n pi over Lx, sin n pi over Lx instead of nx. So you have to keep this in mind. So don't be confused here, you must keep this in your mind and don't forget it. Now let me prove you mathematically how I put n pi over L for the function f of x if it is defined in the interval minus L and plus L or from 0 to 2L. Let's suppose that function f of x has period p equals to 2L. Just suppose that f of x is a periodic function with the period p equals to 2L. I'm going to introduce one new variable which is q, where f of x is a function of q with interval 2 pi. So let me take x equals to pi or 2 pi times q. The value of pi is 2L here. Simplify it further and I have x equals to L over pi times q. So as I can write q equals to pi over L times x. Here I derived two small equations. One is for x which equals to L over pi times q, and the other is for q which equals to pi over L times x. Just substitute the value of x and q in the formula here, where my new formula f of x equals to f of L over pi times q, because the value of x equals to L over pi times q. In cos nx and in sin nx I put the value of x equals to q, where the value of q equals to pi over L times x. Just substitute the value of q here. So my new equation is in the form where I have f of L over pi times pi over L times x equals to a sub naught plus summation of a sub n times cos n pi over Lx plus b sub n sin n pi over Lx. Where at left side pi will cancel with the pi and L will cancel with the L, so I left only with the x. Well, this is my final formula here. That's how I put n pi over L instead of n. I hope you understand this technique. For instance, just keep this in your minds. Similarly, its coefficient a sub naught will equals to 1 over 2 pi times integral of f of x dx with interval minus L to plus L. And the coefficient a sub n equals to 1 over pi times integral of f of x times cos n pi over Lx dx with interval from minus L to plus L. And so is b sub n, which equals to 1 over pi times integral of f of x times sin n pi over Lx dx with interval from minus L to plus L. So you see here that the formulas for the coefficients are different compared to what we had for a function which was defined in interval from minus pi to pi or from 0 to 2L. There is n pi over L instead of n.